So today I'm here to present my work on attention-based ensemble models for emotion recognition in conversation. So emotion recognition in conversation is very important in many research fields, for example, in artificial intelligence and natural language processing. Understanding the emotional context has many applications and it's very important to understand the context. So in this presentation, I will discuss why emotion recognition is important, what are the challenges we have, and how we solve these challenges, the data set we use, the experiments we conducted, and finally, I will conclude my research paper and the future direction for this research. So I will start with what is the aim of emotion recognition in conversation. So given a dialogue consists of number of utterances spoken by the speaker, the goal of ERC is to predict the emotion level for each utterance. So why it is important? It is very important to understand the context of the conversation to better understand what are the speakers saying. So the ability to understand and respond to emotions are very important. There are some applications, for example, in monitoring mental health. By analyzing the conversation, we can predict either the person is suffering from emotional distress, anxiety, or depression. Another application in the customer service, by analyzing the customer behavior, we can detect either it is frustrated or happy with the product. Another application is in the social media analysis, and it is also important in the market research. So beyond these applications, it is also important to understand the general understanding of the conversation. So the importance of ERC lies in its ability to transform how we interact, understand, and correspond to conversation across various domains. So there are some challenges in this domain. The one primary challenge is the complexity involved in learning joint representation that effectively capture the relationship between multiple modalities, for example, text and audio. So for example, text capture the semantic context of the text, and audio refers to the tone, pitch, or other paralinguistic features. So integrating these domains together is a challenging task. Another problem is the class imbalance problem. So many real world data set has imbalance in their data set. For example, neutral or happy are the more prevalent classes, whereas we have low classes for the minority classes. For example, for the fear, we have only 206 ad features samples, whereas for neutral, we have 4,000 utterances. So this leads to bias the models that perform very poor on the minority classes. So how to deal with these two problems? So our approach aims to effectively integrate multiple modalities and improve the prediction for the minority classes. So for that, we propose a cross-model attention mechanism to better focus on most relevant part from each modality, text and audio. So, and we use ensemble methods, bagging and boosting to improve the minority class emotions. So for text, we use Roberta, robustly optimized BERT model, a transformer-based model to capture the semantic content of the emotional text. And for audio, we use Hubert, which is a hidden unit BERT to capture the speech patterns and phonetic content. And then we use the cross-model attention to integrate the features from the text and audio. Um, So we define three set of vectors: query, keys, and values. So a query used to find the most relevant information in one modality, and key is used to define which information is relevant, and values are the information that is attend to and update based on the attention score. So the core idea of cross-model attention is to compute the attention scores between queries and keys to determine how much each element in one modality should attend to element in the other modality. And to deal with the imbalance problem, we use ensemble learning. So basically, we use bagging and boosting. So uh, bagging using the multiple base models on different subsets of data set, and then integrate the prediction from all these base model to give the final prediction. Whereas boosting sequentially train the base models on different subset of data set and assign more weights to the misclassified samples on the previous model. The dataset we use for our experiment is MELT, which is a multimodal dataset collected from the television series Friends. It consists of 7 emotion classes: neutral, joy, surprise, anger, sadness, disgust, and fear. So there are total 13,708 utterances, and they are split into 3 data sets, 3 data set: training, testing, and validation. So we train our model by using the following parameters. Roberta, we extract for Roberta and Hubert, we extract 786 features from the final hidden layers, and then we concatenate these features using the cross model attention model. A batch size of 128 is used, 100 training epochs, and the learning rate is we use 1 e raised to power minus 4, and the error optimizer is used to optimize the model's parameters. And the evaluation parameters to assess the performance of our model, we use weighted average accuracy and weighted F1 score. These are the results for our experiments. So we have 5 experiments, text and audio for single modality. And then we have this cross model with bagging, and the cross model with boosting. So cross model with boosting improve the results on the minority classes compared to the baseline models. And we further visualize our results using the confusion matrix to see how it perform on all classes. So these are the classification accuracies across all emotion classes, and we can see from these neutral perform best in all these in all these experiments, whereas fear and disgust we have low performance. So if I conclude my work is so we propose an attention-based cross-model framework with ensemble learning to capture the complex relationship between text and audio using the attention mechanism. And then to deal the minority class problem, we use ensemble learning, boosting, and bagging. The future work will focus on expanding the capability of our framework beyond emotion recognition to elicit emotions during conversation. So emotion elicitation refers to the process, to the intentional use of language or other clues to evoke specific emotions during conversation. So by integrating emotion recognition with emotion elicitation, we can create more engaging and empathic response. Thank you for your attention.